When designing our DynamoDB database, we need to think about all of our use cases and how we can design our partition and sort keys so that we can emulate a lot of the functionality and queryability we get in a relational database while still getting the great performance and scalability of DynamoDB. Because we are kind of this key value and something a little bit extra type of design with DynamoDB, that's what gives us the ability to do this. And this idea of a single table design where we store kind of semi-structured data of all different data types in one table and then generate secondary indexes in order to link all that together is this kind of complex design pattern that DynamoDB allows us to do. And it's kind of akin to how we design relational databases, but also a very different way of thinking about this, where we may have many tables in a relational database. Kind of the idea in this design pattern in DynamoDB is to have just a single table for an application and capture all of your different types of data in that single data. So to do this, we're going to have just a very simple example with 3 different access patterns here. Write down our access patterns, and we're going to structure our partition key, sort key, and secondary indexes to try to capture these requirements. So far, we have just created our DynamoDB that has some courses per department. But let's say we also wanted to capture some additional information about our department, like the name of the department, who the department chair is, and the faculty members that are in that department, and then of course the courses that are offered by that department. With this basic kind of database design, we're going to see that it's going to be pretty easy to be able to find all the faculty members in the department and all the courses in the department. But then when we start putting together what we would typically think of as a many-to-many relationship in a relational database, finding something like all the courses a faculty member teaches, that's going to be a little bit trickier, okay? And we're not going to be able to get into super depth on this, but do at least want to get you guys kind of thinking down this path a little bit. So since we're going to be storing items of all different types in one table, whereas previously we had called our partition key and our sort key department and course, if we're going to be storing all different types of data in this one table, that's not going to be an accurate description of what those values are in many cases. So the general guidance there is going to be to have a generic name for our partition key and for our sort key. Just call them PK and SK or something like that. And then all of our other attributes can be descriptive because we can have different attributes for each item in our table, okay? So we're going to have this basic structure. We're going to call our partition key PK, our sort key SK. And in this case, we have these 2 attributes describing our department, the name of the department and the department chair. And then notice for the values of PK and sort K, we've done a kind of weird thing here where we have a prefix for the value of DPT, just really kind of indicating that this value is describing the department. Okay, and then we have a hash sign, which much like the colon we used in the Redis examples, is nothing magic. This is just a string, right? And DPT does not mean anything special in this case, okay? This is just a way that we kind of as humans are understanding the structure of our data, okay? And this is going to make a little bit more sense as we continue building this out. So DynamoDB is going to assign our items to partitions based on some common value of this partition key. So at this point, it's anything that has a partition key of DPT hash disk is going to go onto one partition, and things with DPT hash marketing are going to go into another partition, which may or may not be on different servers, okay? But everything that's in this partition is going to be physically located close together, because the assumption is we're going to want to access things that have the same partition key together, right? These are similar related items. So now building this out a little bit more, when we start adding our faculty members, well, faculty members from the same department are going to have the same partition key. In this case, disk for our faculty members that are in the disk department, and MKTG for faculty members that are in the marketing department. So they have a similar value for partition key, but then have a unique value for sort key within the partition key. Okay, so it's the combination of the partition key and the sort key that makes the primary key unique. But when we go to store all of these items within partitions, because these three faculty members and this department have the same partition key, all of that data is going to be stored together in one partition, and all of these faculty members that have a value of DEPT hash marketing are going to be stored together in another partition, okay? And kind of the basic idea here being, if I'm interested in one faculty member in the disk department, it's more likely that I'm going to be interested in other faculty members of the disk department than I would be interested in faculty members of some other random department, right? I'm gonna address all of these items kind of as a whole based on some common value of the partition key. So now taking this, or before we take this one step further, one thing that we do need to be aware of in DynamoDB is that we can only search based on values of our primary key. So if we want to search by something like last name, we're going to have to create a secondary index. And so when we do that, the value that we're creating this secondary index on is going to become the primary key of the index that we're creating. And then the only attributes that are required to be, or the only additional attributes that are required to be a part of this secondary index are the primary key and or the partition key and the sort key, or whatever makes the primary key, from the source table that we're creating this secondary index from. Okay, so if we wanted to be able to search on last name, the secondary index is going to have a primary key of lname and then attributes of the primary key of the base table on which this index is being created. So when we look up Johnson, then we see, okay, the primary key and the sort key of the source table are dept disk fac in Johnson, which is going to immediately point us to the correct item in that source table, right? So now, originally, when we wanted to look up a faculty member based on their department and their what looks like a username in this case, that's a very fast operation in DynamoDB to look this up. But looking up based on last name would be very slow because we haven't indexed that. So when we create this index, that's one very fast operation to find the last name, which points you to the partition key and sort key, which is then a second very fast operation to look that up in the source table. So it's 2 steps instead of 1, but it's 2 very fast steps. Now to carry this one step further, and to look at this third use case, so we just said that it's, I think the first 2 use cases that we wanted was to be able to look up a faculty member and look up a department. And both of these things are very easy in this design, but then we wanted to be able to look up all the courses that a faculty member teaches. And we said this was going to be the harder query to write. So now when we add to our single table, not just departments and faculty members, but also courses, okay? Courses within a department are going to have the same partition key, right? Because that course is part of the department, and then a different sort key, and we have some different attributes than we have for either department or a faculty member, but then how do we link together what faculty member these courses are being taught by? The way we do this is by adding another secondary index, which is going to point back to the value of the partition key and the sort key of the faculty member that teaches this course. Okay, and then we're going to create a secondary index based on these attributes. Okay, so for our course items, we have attributes that describe the course, like title and type, but then we're creating these additional attributes, GSI1PK and GSI1SK, that are capturing information about the faculty member that teaches them. In this case, this represents the partition key and the sort key of the faculty member that teaches it. And then for the GSI1SK, this is representing the course that this is describing. And we're going to see why this is necessary in just a second, because we're going to create now a secondary index on these attributes. And this is going to be the partition key and the sort key for that secondary index. And it's going to return the partition key and the sort key of the item that this is referring to. Sorry, it's kind of hard to say this. So maybe on the next slide, this is going to make more sense. So when we create this secondary index, we're taking these values, and that's the partition key and the sort key on this secondary index. And then the two attributes that we are also returning in this secondary index are the partition key and the sort key of the item that this originally corresponded to. Okay, so the neat thing that I'm going to point out here is that because we have the same faculty member teaching these two courses, they have the same partition key in this secondary index that we create, right? Dept, disc, fact, mgrimes. So both these two courses and the faculty member record have this same partition key. Okay, and then the same thing for this course that's being taught by our other faculty members. So now when this secondary index is created, these three records are all being stored together. So to look up who teaches or what all courses a particular faculty member teaches, that's going to be a very fast lookup, which is going to point you to these partition keys and sort keys, which are then in the second operation going to be a very fast lookup. So it's a little tricky to get your head around, but by kind of being careful with how your partition keys and sort keys are defined and then strategically creating secondary indexes on that, we can create very rich and robust tables which are going to be very fast to query in just one or two very fast operations. So in this way, DynamoDB can store a much more robust kind of data structure than we can with Redis. But Redis, on the other hand, is going to be kind of faster and a little bit more nimble than DynamoDB. But it's really just two different solutions that have a similar underpinning of this key value data store, but that are meant to solve very different problems. So at any rate, that's kind of the gist of DynamoDB. It's consistently fast, it's very robust, very powerful, and it is a persistent data store, unlike Redis. So it's kind of a different tool for a different job. Can be a little tricky to design, and in fact, if it's improperly designed and you're using a whole bunch of tables in DynamoDB as opposed to this one table design, you might actually get worse performance than you would with other systems. So Again, just want to get you guys a little bit of exposure to all these different systems, and as you start applying them in the real world, you'll come to appreciate more kind of the richness therein all of these.